All right, we will start with optimization. We'll start with an easy example. Example one. Let's say that you are required to find the multiplication of two numbers. Let's name this function as C, as in cost function. Find a multiplication of two functions or two variables, x and y. At the same time, these two variables, their summation is equal to 5. Okay. So find the best optimum solution for this problem. Okay, we will start with the first method, method one. This method is called the substitution method. Okay, the first thing is to change the auxiliary function. This is called the auxiliary function. To change the auxiliary function to the respect one of the variables, I will choose y. So y is equal to 5 minus x. Okay, now substitute this value in the cost function to be just like the following. So you have x, 5 minus x equals, simplify this, 5x minus x squared. Now you need to find the derivative of the cost function, dc over dx. So the derivative is 5 minus 2x, okay, equal to 0. It's always equal to 0. Now solve this. You will get that x is equal to 5 over 2. Okay. Now substitute this value here. You get y. 5 minus 5 over 2 equals 5 over 2. Now this is the value of y. Now you have these two values, y and x. We need to substitute them in the cost function to know what's the maximum or the minimum, depending on the problem, number possible using these two numbers. So you'll have 5 over 2 multiplied with 5 over 2, you'll get 25 over 4. Okay, you can see that's easy. So that's the solution of the problem using the first method, the substitution method. Now method 2 is unapplicable. It's called the implicit method, but it's not working on this type of problems. So we will have the third method, method 3, called the Lagrange or the Lagrangian. Some courses call this Lagrangian multipliers. Anyway, this method works on the function L, Lagrangian, which is cost function, plus a constant or a variable from your own choice. I will choose lambda with the auxiliary. Okay. Now the cost function is, remember, the cost function is the function that does not have a value, which is in our case is x, y, and lambda as it is, and the auxiliary you have it as x plus y equals to 5. You change this to x plus y minus 5 equal to 0. So you'll get this, plug it here, x plus y minus 5. Okay, now you need to find the partial derivative of this problem. Get partial L over partial x. You'll have y plus lambda, yes, equals to 0. This means that y is equal to negative lambda. We'll do the same thing for y, partial y. You'll get x plus lambda equals to 0. You will have x is equal to negative lambda. Now, going down. Okay, partial L over partial lambda will just give you the auxiliary, which is x plus y minus 5 equals to 0. Now plug in the new values that you have. So you'll have negative lambda, negative 5 equals to 0. So you'll have negative 2 lambda. Take the negative 5 to the other side, you'll have a 5. Then lambda is equals to negative 5 over 2. Okay, now plug this value back here, and you'll get y is equal to x equals to 5 over 2. Okay, again, you need to plug this back to the cost function xy, which, as we found before, that it's equal to 25 over 4. Okay, these are the first two methods in optimization in our first simple problem. Now we'll have a different problem. You have, let's say you have a wire, okay, a 40 meters wire, and you're required to find two different shapes out of this wire. Okay, a circle, and this is supposed to be a square, but anyway, a circle with a radius r and a square with a side s. Okay, so in order to make these two shapes, you need to find their circumference. So the circumference equation, the circumference of a circle and the parameter of a square. Anyway, so the summation of the parameter and the circumference should be equal to 40. So you'll have 40 equals the circumference of a circle, which is 2 pi r, and the parameter of a square is 4s. Okay. In this case, you can see that you can simplify it. It's not mandatory, but just do it to look better. So you'll have 20 equals pi r plus 2s. Okay, this is our auxiliary function. As if our cost function, you're required to find the best values for r and s to find the maximum or the minimum area. So we'll have the cost function is the summation of the areas. So the area of a square, it's s squared, and the area of a circle, it's pi r squared. Okay. Now we will use the substitution method, method 1. Okay. The substitution method means that we will use one of these variables as our independent or dependent variable, like our main function. So I will choose s. Personal preference, you can choose r, depends to you. So you have 20 minus pi r over 2. That's our s. Okay, just plug it here, and you will have 20 minus pi over r 2 plus pi r squared. Okay, so the method 1 will use the derivation. So you'll have dc over dr. Yeah, there's a square here. Anyway, dc over dr. We will use chain rule to just make this simple instead of expanding the brackets. Okay, and the differentiation, what's inside the bracket, it's negative pi over 2 plus pi r squared equals to 0. It's always equal to 0. Sorry, not pi r squared, it's 2 pi r. Anyway, so you'll have this form. You can see that there are some simplifications you can use. You can cancel the 2 from here, and you have a pi. Cancel it. You'll get 20 over pi r. Sorry, minus pi r over 4 plus r equals to 0. There's a negative here. Anyway, so to solve this, multiply by negative 4 to get rid of the 4 and the negative here. And you'll get 20 minus pi r minus 4r equals to 0. Now you can see that we have an r as a common factor and we have a constant here. So just rearrange it. You will have the following: pi r plus 4r equals negative 20. No, it's equal to positive 20. Okay. Take the r as a common factor and you'll get pi plus 4 equals 20. Then r is equal to 20 over pi plus 4. Okay. Now plug in the value of r back in the auxiliary function, which is the auxiliary. Again, the summation of the parameters, 40. We're using the newer one, 20 equals pi r plus 2s. Noting that if you use the one with the 40, it's fine, just as long as it's correct. Anyway, so pi 20, there's no negative here, 20 pi plus 4 plus 2s. Okay, that's an s. You'll get that s is equal, after solving this, s is equal to 40 over pi plus 4. That's the value of s. Okay, that's our first method. As for our second method, of course, you need to substitute these value back in the cost function, but you can do it, it's easy. Okay, now to our second method, the implicit, okay? Method 2, it's called the implicit. The implicit method, you need to use, again, both the auxiliary and the cost function that you found earlier. The cost is, the cost function was s squared plus, yeah, s squared plus pi r squared, and the auxiliary, you had 20 equals 20, or we'll not use this one, we'll use the value of s. It's fine, you can use any one of them. 20 minus pi r over 2. Okay, now we need to find the derivation of this. Okay, the derivation ds dr, it's equal to negative pi over 2. Okay, now we'll have the cost function. We need to differentiate it without substituting yet. dc over dr. Now noting that s is a function of r, so it can be differentiated. It's not a constant in this case. So you'll have 2s ds dr plus 2 pi r equals to 0. Cancel the 2 from here. Okay, you have an s here. Substitute the value of ds dr. It's 2 negative pi over 2 plus pi r equals to 0. A pi can be cancelled with a pi. Eventually, you will have negative s over 2 plus r equals to 0. So this r means that it's equal to s over 2, or s is equal to 2r. Both are the same. You can use any one of them. Now substitute the new founded value here, or this, depends to you. I'll choose the second one, personal preference. Substitute it back in the auxiliary function. Where's the auxiliary function? Okay, where is it? Okay, the auxiliary function. Substitute it back with the auxiliary function. You will have 20 equals 2s minus pi r. Is that correct? Sorry, my handwriting is bad. Okay. Okay, there's no minus here. There's a positive one. Anyway, so plus pi r. So 2s is equal to 2r plus pi r. You get 4r plus pi r. R as a common factor. 4 plus pi. 4 plus pi. Eventually, r is equal to 24 plus pi again. Now substitute this back in the original auxiliary, and you will get the same value of s, which is s is equal to 44 plus s. Or not in the auxiliary, just substitute it back here. Yeah, back here. You get this. Okay. Now again, as I said before, you need to find the new cost function with its actual values. Okay, that's our second method. Now let's go to the third method. Just check the meeting if it's working. Yes, it's working. Anyway, method 3, the Lagrangian, L is equal to the cost function, which is s squared plus pi r squared plus lambda, the auxiliary 2 pi r. I'm using the old auxiliary. As I said, you can use the old one. It doesn't matter. It's just the same. I prefer to use the new one. 2s minus 20. Now find its partial differentiation to the respect to each variable. So we'll have partial L over partial S. 2s plus 0 plus 2 lambda equals to 0. S and lambda can be cancelled. Just making sure if my calculation is correct. We have a 2s here. 2s. Okay, it's correct. Then s is equal to negative lambda. Now let's do partial L over partial R. We'll have 2 pi R plus lambda pi. Okay, equals to 0. A pi and a pi can be cancelled. Eventually, lambda or R, let's say R, is equal to negative lambda over 2. Now you have these two values. Substitute them in the auxiliary. The auxiliary, I think that you need to do this. Partial L over partial lambda is equal to the auxiliary. So you have pi r plus 2s minus 20 equal to 0. Substitute the new values. So we'll have pi negative lambda over 2 plus 2 negative lambda plus 20 equal to 0. And you will have, simplify this, get rid of the 2. So you'll have negative pi lambda negative 4 lambda negative 40 equals to 0. Take this to the other side by positive, cancel it. Then you will get lambda as a common factor here. Negative lambda pi, negative 4. Okay, this is a negative. Okay, yes. Equals to 40. So lambda is equal to 40 over negative pi, negative 4, or negative 40 over pi plus 4. Now we will use the values again of s and lambda. We can see that s is equal to negative lambda, so negative 40, 4 plus pi, you'll get 44 plus pi. And as for r, it's equal negative 40, 4 plus pi over 2. Negative and negative can be cancelled. 40 over 2. You will have 24 plus pi. And these are the same values that you found in the previous two methods. Okay, now let's solve a third problem, and it's going to be our last problem, inshallah. This one is slightly different with 3 variables this time. So we are having this type of 3D function, 4x plus 2y, that's a y, okay, plus z equals to 20. And we were required to find the distance, or the minimum or the maximum distance from this function toward the center of the xyz plane, xyz plane. And this is the center over here. And the function is somewhere in whatever is it. Let's say, for example, it's here, just saying, okay, we're required to find the best distance possible for this function. So we will use the distance function. The distance function, you can find it the following. This is the equation of the distance from the center. X squared plus y squared plus z squared. Okay, this is equal to d squared, going to be our cost function. So ignore the d, we'll use the c as our variable as usual, or our function. Okay, the first method, method 1, substitution method. We are going to change this and the auxiliary to the respect to one of the variables. Looking at this, finding that without any division, you can just choose this one as your dependent variable. So z is equal to 20 minus 4x minus 2y. So you'll have to substitute this value back in here in the cost function. So c will be equal to x squared plus y squared plus 20 4x to y squared. Now you're not required to expand this. Going to find here, previously we saw that we used dc over dx or dr. You can see here that we're having 2 variables here. So we'll use partial differentiation instead. So partial differentiation of c over partial x is equal to 2x plus 0, because this is just an independent variable on x, plus chain rule here, 2, 20, 4x, 2y, and the differentiation to the respective x, which is inside the bracket, which is going to be negative 4. So you see that's differentiation of this is 0, the same thing here, so only this one is differentiable. So equal to 0. You can see that there's a common 2 here, cancel it. So we'll have x, and put the negative 4 here, multiply it. So x negative 80, positive 16x, positive 8y equal to 0. Now rearrange this to have a better function, usable one. So we'll have 17x, and negative 80 goes to the other side, and we have an 8y. So this is our first function. Okay. Now for our second function, we need to use partial differentiation again, but this time to the respect of y. So you'll have 0 plus 2y. Okay, plus 2y plus 2. Again, a chain rule, 20, 4x minus 2y and the differentiation of what's inside the bracket, which is going to be -2 equal to 0. Okay, now cancel the 2 since it's a common factor. You'll get y -40 plus 8x positive 4y equal to 0. Now rearrange this again. You will have 8x plus 5y equals to 40. Now this is going to be our second function, or second function. So you can use these two and this with any method that you like. You can use the matrices, you can use substitution method, you can use any method that you like. Since calculator is not allowed in this course, you can use any method that you learned previously. Anyway, the answer will be for these two, x will be equal to 80 over 21 and y is 40 over 21. Okay, now use these two again in the auxiliary function, which is z equals 20 minus 4x minus 2y. Just substitute these values back. So we'll have 20 minus 4 times 80, which is 240. Yes, I guess so. 240 over 21 minus 20 over y. Substitute, sorry, 20 over, sorry, over 21. Okay, find the result. It should be, just don't have the answer here. I think z is equal to 20. Z is equal to 20 over 21. Yes, that's the value of z. Okay, you can recheck with yourself. Now, but now go to method 2. Method 2, the implicit. So you need to find the partial differentiation, the implicit partial differentiation of the cost function. Let's have our cost function just right in front of us, so things won't be confusing. Cost function is x squared plus y squared plus z squared. Okay, this is our cost function. And we have our implicit, which is, again, z 20 4x 2y. Okay, this is our auxiliary. Okay. So partial c over partial x. You see, this time we're not substituting this like in the beginning, we'll substitute in the end, but in a slightly different way. So 2x and y is an independent variable, so it's going to be 0. About z, z is a function of y, so you can differentiate it. So you'll have 2z dz dx. You can see the difference here. Okay, equal to 0. So what's dz over dx? Is simply differentiate this to the respect of x, or partial z over partial x, doesn't matter. So we have 2x plus 2z dz over dx, which is -4, equal to 0. Cancel the 2's. So we'll have x -4z equals to 0. So x is equal to 4z. Okay. Now go to the second variable, partial c over partial y. Get 0 plus 2y. Again, z is also a function of y, so it's going to be differentiated to 2z dz over dy. So the dz over dy is equal to, you can see this can be 0, 0, so you'll have only this -2y. Differentiate -2y, it's going to be -2. So yes, this is equal to 0. Cancel the 2's here. So we'll have y plus z -2 equals to 0. So y is equal to 2z. Okay, you see what you have here? You have two variables are now with respect of z. Now you can substitute these back in the auxiliary function which is again z equals to 20 minus 16z minus 4z simplified. After simplification, you can get 21z equals 20, and you'll get z is equal to 20 over 21. Now plug these back here. So we'll have y is equal to 40 over 21, and x will be 80 over 21. Now just check it with the original values that we found before, and you'll see that we have the same values here. Okay. Now let's go to method 3. Method 3, the Lagrangian. With the cost function first, x squared plus y squared plus z squared plus lambda is the auxiliary here. 2y plus z, negative 20. Okay, so you have partial L over partial x. You'll have 2x plus 0 plus 0. You don't have any dependent or independent, just simple partial differentiation. Plus lambda equal to 0. So x is equal to lambda over 2, negative lambda over 2. Is that correct? No, it's not. Okay. So the differentiation with respect of x is going to be 4 lambda, which will have negative 2 lambda as an x. Okay, so partial L over partial y, you have 2y plus 2 lambda equal to 0. You will have that y is equal to negative lambda. Okay, go back to the Lagrangian. Partial L over partial z. You have 2z plus lambda equal to 0. So z is equal to negative lambda over 2. Now substitute this in the final partial differentiation, which is partial L, partial lambda, which is our auxiliary. 4x plus 2y plus z minus 20 equals to 0. Now use the new founded variables out of lambda. So we'll have negative 8 lambda, negative 2 lambda, and negative lambda over 2 equals 20. Take the 20 to the other side. Solve this, and you will get that lambda is equal to negative 40 over 21. Okay, now substitute this back here. So you'll have y is equal to 40 over 21. Z is equal to 20 over 21. And the x is equal to 80 over 21. You can compare these new values with the previous values that you used in the implicit and the substitution method, that you can see that they both are the same. So that's it for optimization. I think that's it. All right, the tutorial just ended.